Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, for the past 5 weeks, we've been covering I/O-related topics, and for the past 3, including today, it's all about new aspects of OCS-I. Here's our specific topic for today: configuring OCS-I. And as we explore the configuration of OCS-I with a lot of hands-on demonstrations today, before we do that, I'm going to bring in our product manager, Mr. Casey Gardner. How you doing today, Casey?
Hey, not too bad. How's it going, Chuck?
It's going terrific. Now, as the product manager, you're responsible for kind of specifying the features and functions of new products. And with OCS-I, one of the things that needed to be specified was configuration. So what were some of the design goals for configuration with OCS-I?
Sure. So I think a lot of it, we tried to strive for simplicity first and foremost. I think that was one of the big things that stuck out was being able to configure it easily, for sure. So in terms of we have instances where one rack of I/O is probably the most common, whether it's a full rack or partial or not. But in those cases, there's a lot of times where it doesn't need a lot of configuration in the field to do so. It's kind of a plug-in once you've got a program already with a little bit of information to it, such as mapping registers or things like that, that it just is up and running kind of thing. So there's not a lot of field support needed for it. It's just kind of a plug-and-go type system once you've got the right program in there. So that was definitely a big key. We also wanted to make it an automatic type system where, again, it recognizes how many I/O modules are plugged in and be able to see that and visualize it from a system menu configuration type capability as well. So those were some of the keys anyway.
Terrific. Yeah, I mean, making it easy, making it simple, especially in those situations where you've got a single rack, which is the majority of the cases, that's definitely important. So I think we've hit that from the time I've had a chance to play with OCS-I. I think we've definitely hit that, ease of use and simplicity. Now, is there anything else in the development right now that might have an impact on OCS-I configuration that's coming down the pike?
Sure. So one thing that's not going to be in the existing Cscape configuration today that will be in the future is basically the ability to dynamically configure some of the analog modules. So things like the ADU that we've covered previously, which is a universal analog input module, or we also have an analog output module. Things like those, being able to configure those channels individually on the fly is something that customers can expect to be able to use in the future as well.
Yeah, so if I'm an OEM and I've got a machine that does temperature control, and some of my customers like to use thermocouples and others like to use RTDs, and I'd like to have the same Cscape program controlling my machine and have the customer select the sensor in the field, that'll be a capability that will be available later on this year. Terrific.
Absolutely.
All right, sounds great. Okay, well, thanks for joining me for these past 5 weeks for covering I/O, and we'll see what is planned for the next few weeks. All right, thanks again, Casey. Take care. All right, we're going to explore now the agenda for today's topic. We're going to start by taking a look at the general configuration process for OCS-I. We'll look at simple single-base systems and a little bit more complex multi-base systems. We'll take a look at the tools that are available built into the OCS system menu that you might take advantage of if you're using OCS-I. We'll take a look at all the individual configuration options for the I/O points that are built into OCS-I. If you're talking thermocouples or RTDs or digital I/O, what are the configuration options? And we're going to do plenty of demonstrations throughout. Now, one thing we're not going to cover this week, and that is doing your configuration on the fly, like Casey talked about in the opening. We're going to cover that in another program where we can cover not only configuration at runtime for the CNX base, but also configuration for the individual modules. That's a capability that's being released with Cscape 9.9 Service Pack 9. So it's not quite here yet. We'll cover that in a future session. Okay, here we go. Let's start with general I/O configuration for OCS-I, starting with single base systems. Now, configuration is performed from Cscape, and it can be done completely offline. You don't need to have your equipment present in order to do configuration of OCS-I. However, if you do have your equipment and you can set up Cscape, your OCS, and your OCS-I to all be connected and online, then the bases can be auto-populated in Cscape, which will save you some time. And then once the base has been added and auto-populated, you'll just have to fill in some remaining details. What remaining details? Well, let's take a look at a few of them. Now, there will be a default base name that is suggested, probably just base 1 or something like that. That's really just used for documentation purposes, but you might want to give it your own more descriptive name for your project. It'll suggest a network ID, which you may want to leave alone, you might want to change. It will also prompt you to set a status variable, which I definitely recommend you do. The status variable will allow you to see all kinds of diagnostic information for OCS-I. So you'll need to assign that. If you're using register-based I/O, it'll be a series of 15 consecutive %R type registers. If you're using variable-based ladder or IEC-based programming, then you're going to set up a integer type array with a dimension of 15. Another thing you'll need to do is to set the starting addresses for the digital inputs, the digital outputs, the analog inputs, and the analog outputs. So that's something that definitely will need to be done. It will suggest a communications timeout, the default being 1 second. That's the amount of time that the OCS-I base is willing to wait for communications from an OCS. If it doesn't hear from an OCS over that time period, it will go into a safe state. So those are the details that need to be filled in, some of which will have suggestions or defaults that you can override. Others you'll just need to fill in from scratch. One thing I didn't really cover on that last dialog box is in that upper right-hand corner there, one thing that was listed was something called a UUID. So what is a UUID? Well, it's a special kind of serial number. Very detailed serial number. It's actually 192 bits. It's typically represented by 6 consecutive 32-bit hex numbers. Now, the whole purpose of the UUID is for there to be a unique serial number for every OCS-I base that's shipped. Now, this is not a serial number that we put in at Horner. This is actually a feature of the microprocessor that we're using, and it's assigned by the microprocessor manufacturer. And we're just taking advantage of this unique serial number so that the OCS can keep track of the fact that you have multiple bases that are different, okay? And the UUID is how they're differentiated. Now, with SmartRail, for instance, you've got rotary switches to differentiate between one base and the other. You don't have rotary switches with OCS-I. It's completely rotary switch free. So the UUID is how two bases are differentiated from each other. But don't worry, you're not going to have to type in that big long number. For a single base system especially, the OCS really doesn't have to utilize it to differentiate between bases because there's only one base. And even if you're using a multiple base system, there are ways of configuring, which we're going to show you, a multi-base system that don't require you to really know the UUID either. So we've talked about single base systems. You do everything in Cscape. You can do it completely offline, or you can go online with your OCS and your base, and you can effectively have everything auto-populate. Well, it's very similar with a multiple base system. The only real difference is this. With a multi-base system, if you want to take advantage of auto-population, then you will bring up one base at a time, starting with the base that you want to be considered the first base, or usually base 1. Okay? So you'll get your Cscape talking to your OCS controller. It'll be connected to the first base, whatever you consider the first base. You will effectively add your base and auto-populate that base. Once that's done, you'll add the next base and auto-populate that one. When you're done adding your last base, then you go back and fill in those details. So very similar. The only difference is you bring up one base at a time in the order in which you want them to be numbered. Okay, now let's talk about some of the system menu tools that are available in the OCS if you're using OCS-IO. Now, one thing I will mention here, and that is this. Remember, as we are broadcasting this, not all OCS families have support for OCS-IO yet here in early February of 2023. So the XL series, the XL Prime series, and very soon the Micro series will have support. So if you're not seeing the menus that I'm talking about here, then either you don't have new enough firmware, and the firmware is available and you just need to do your upgrade on your OCS, or in the case of the Micro OCS, for instance, maybe that version of firmware that supports OCS-IO isn't quite ready yet. Okay, but let's take a look at what the system menu tools look like for the OCSs that have support for OCS-IO. So for those units, you're going to go to the system menu, then you are going to select View I/O slots. After you select that, the next menu will have OCS-IO configuration as an option. So once you select that, what kind of functionality will you get? Well, on that screen, the OCS-IO configuration screen, you're going to be able to see all the bases that are configured with their name, their network ID or CAN ID. You'll see their status, if they're enabled or maybe if they're faulted, okay? You'll see the UUID listed there in that long number, and then you'll see all the modules that are connected to that base. And you'll see all those details even if you have a multiple base system. And in the case of a multiple base system, if you ever need to replace one of the bases for whatever reason, then you will use the system menu to actually do the replacement. And we're going to demonstrate that later today in the program. Okay, now we're going to go through some of the I/O configuration options that are available for the different types of I/O points that are available with OCS-IO. And I'm not going to spend a tremendous amount of time on these, but I want to show them to you so you'll get an understanding of what the options are. But actually filling out, doing the configuration on a module by module basis, that's very straightforward. It's really just plug and play. Let's start with digital I/O modules. So this isn't any one particular module, but any OCS-IO module or the I/O built into the CNX base, for instance, that is digital in nature, whether it's an input or an output. So 99% of the time, the default configuration for a OCS-IO digital I/O point is going to be just fine. Okay? The types of things that you can change are things like filtering and the halt state, those sorts of things that typically you're not going to change very frequently. Now, the one thing you might change occasionally would be if you ever need to configure the I/O points for negative logic instead of positive logic, then you would go into the configuration for that particular module and change the input configuration from positive logic to negative logic. But that's the exception. 99% of other cases, you're just going to leave it at default. Okay, next let's talk about our ADU100. That's our Universal Analog Input Module. What kind of configuration options does it have? Well, at the top you've got a digital filter. Basically, that is a setting between 0 and 7 you can use as a compromise between stability and response time. At the bottom, you have an update time option that has a default of 500 milliseconds. That can be set so that the ADU100 module will know how often it needs to broadcast a new set of values for the analog input channels. Now, 500 milliseconds is the default. You might want to speed that up a little bit in most applications, maybe down to 50 milliseconds or even 25 milliseconds. Again, that's the amount of time or the frequency at which the channels will be updated by the ADU module through the base to the OCS. All right, we're still on the ADU100, which is our Universal Analog Input Module. Of course, you have your choices on a channel-by-channel basis for the different type of sensor or signal that you want to be compatible with, as well as the data range. If you're talking about a traditional analog input data range, your highest resolution is going to be 0 to 32,000. You have some other ranges you can choose there for convenience. If you're talking temperature, like a thermocouple or RTD, you can choose between degrees Fahrenheit and degrees Celsius. Your readings are going to come back in 10th degree increments. Okay, moving on to our 4-channel analog output module. It's very similar to the analog input module in terms of its configuration. You configure the channel type, you configure the data range. The only extra thing you have there is something called a halt state. So what happens to the output when the OCS goes into stop mode or stops communicating with the OCS-I base? So you have your choice there of what needs to happen in that scenario. One other thing I will mention, and that is the 4-channel analog output OCS-I module does support minus 10 volt to plus 10 volt. So not a lot of I/O systems these days do support that range. It is supported with OCS-I. Okay, now let's take a look at the built-in I/O that's in the CNX base itself. Remember, we've got 6 I/O points. So let's start with the one universal analog input point that we have built into the CNX. You'll see it configures very much like the ADU100's universal analog inputs. You select your data type, your data range, and your filter constant. Now, the CNX has 2 flexible inputs that can be either digital or analog points. If you use those points in digital mode and it's channel by channel selectable, you get to choose your voltage range between 24, 12, or 5, and even a custom range in case you have something unusual there. And of course, positive or negative logic. If you're using those flexible inputs in analog mode, again, you select between voltage and current, and you select your data range. Okay, now going to the output channels, you've got 1 channel of analog output and 2 solid state outputs. For the analog output, you can choose the signal type as well as the data range, as well as what happens when the controller goes into stop mode. What do you want the output to do? On the digital side of things, it's just like any other digital output with OCS-I. The only thing to really configure is if you want it to do something unusual from a hold last state standpoint when the controller goes into stop mode. Generally, you don't. You just leave it at default. Okay, now we're going to start our series of demonstrations on doing actual configurations. And we're going to start with a single base system, and then we will transition to multiple base systems. Okay, here's our first bench setup. I have a OCS-I rack that I physically assembled here. I have it connected electrically to my OCS through CAN cable here. It's actually a modified patch cable like I've shown before. All right, I have a terminating resistor installed on the second MJ port here, or RJ port here on the OCS-I base, and the OCS-I base is not powered up yet. Let's go ahead and power it up. Okay, I'll plug it in here with the power. All right, you can see we have flashing lights as it powers up, and I wouldn't expect that to change because the program I have running here in my OCS doesn't have any OCS-I configuration at all. Okay, I haven't gotten to that step yet. All right, I'm going to take a shortcut to the system menu that I've created here on my screen. Oh, that's not going to work though if I don't have the controller in run. So that just goes to show you that even the most experienced programmer can forget to put controllers back in run after they do their programming change. Okay, so now we're in run. So now I should be able to hit this button and actually go to the I/O menu in the system menu. That's a shortcut I created. I'll hit enter again to take a look at the OCS-I configuration, and there are no OCS-I bases configured, as I mentioned earlier. So we're starting from scratch, effectively. Physically assembled OCS-I, electrically connected, powered up, but no configuration at this point. Okay, now let's jump to Cscape, and let's go into the hardware configuration. And we need to go to our CAN tab where our OCS-I is physically installed. So I'll do that here now. Again, there is no OCS-I configuration or any other CAN remote I/O configuration right now. I'll hit the add button. I'll go to the OCS-I tab and select the CNX base. Now, I'm not going to hit OK here. I'm going to hit auto populate all. The reason this is going to work is because I am online with my OCS right now, and my OCS-I/O is powered up and physically connected to the OCS. So I'm going to hit the Auto Populate All button. Okay, it's asking me if I want to auto-populate the I/O bases, letting me know if there was anything in here before, it's going to be overwritten. I wish to continue. Okay, we give it a few seconds, and it comes back and says, hey, here is an OCS-I/O base that I found with this UUID. And remember that UUID is a unique number, effectively almost like a serial number, but a unique number that is shipped with every single OCS-I/O base, CNX base, that we ship at Horner. So that's what it found. All right, it's asking me if I want to assign this net ID to its respective bases. The answer is yes, I do. Okay, so it is going out and checking out all the modules. It found them all, we think. It tells me the auto-populate is complete. All right, it says, hey, we've got a success with this UUID. And we say, okay. All right, and okay again. And there we go. We've got our OCS-I/O base, which is a base with 3 modules. If we take a quick look again at our bench, sure enough, that's what we have. But we're still not talking. As you can see, we still have flashing lights, plenty of flashing lights on the base. All right, so back to Cscape. All right, now this is kind of the automatic portion of the configuration that is now complete. The reason we can't do it all in one fell swoop is because there are some things we do have to manually tell the base in terms of how we want it configured. So we're going to start with the I/O base, and we're going to double click here. Okay, and we're going to give it a meaningful name to us. Now, base 1 is what it's called in automatic configuration or auto population. We could leave it like that, or we could just go ahead and give it a new name. So I'm going to do that now. I'm going to call this OCS-IO_1. That's what I want to call it. All right, network ID of 1 is perfectly fine. I'm going to assign a status register. Now, I've previously created a status register variable that I will assign here. Okay, it is 15 consecutive words. So I reference the first element of the array. And then here, from this point forward, I need to assign the digital in, digital out, analog in, and analog out real-world I/O registers where I want all the OCS-I/O in this base to start. Okay, and in my case, I'm going to have them start at %I65, %Q65, %AI65, and %AQ65. I'm doing that because I know those particular addresses are well away from where the built-in I/O is mapped, so that's what I'm going to do. Now, because I'm using variable-based advanced ladder, I'm not going to type in %I65, for instance. No, I'm using variable-based advanced ladder, so I need to reference one of the variables built into the project. Now, by default, there is some real-world I/O arrays I can choose to take advantage of, and I'm going to do that here. So I'm going to use I64. Okay? Now, why 64? Well, remember, arrays are always 0-based. So %I65 references I64. Always the index is 1 less than the actual 1-based memory address. Okay, so I'm going to fill in the rest of these. And again, it's my choice is where I map these. I just want to make sure I put them in a location where they're not going to conflict with any other existing I/O. Okay, like the I/O that's built in, for instance. Okay, so I've got those populated the way I want them. I'm going to say, okay. Now, what else do I need to configure? Well, any of the I/O that isn't just digital I/O, I'm going to need to configure that. So let's go back to the base. I'll double click on the base. And this time I'll go to the onboard I/O tab. All right, and I'll go ahead and configure the onboard I/O the way I want it. So I'm just going to do this relatively quickly. For my universal analog in, I'm going to say I want that to be a 4 to 20 milliamp input with a range of 0 to 32,000, because after all, this is a 16-bit analog input. I'll assign a little bit of filtering for stability at the cost of a little bit of response time. I'll skip over alarm configuration at this point. On my 2 smart inputs, or we don't call them smart inputs, we call them flexible inputs. On our 2 flexible inputs, I will enable channel 1 and make it a digital input of 24 volts. And I'll enable channel 2 and I'll make it an analog input. And let's say I'm going to do it for 0 to 10 volts. Now this is a 12-bit analog in, but I'll still choose a range of 0 to 32,000. And then I'll go ahead and enable my analog output, let's say for 4 to 20 milliamps with a range of 0 to 32,000, because I always like to have the maximum resolution available, although this is a 12-bit analog out. So 0 to 4,000 would be just as good. And on the halt state, when that analog output is turned off, I want it to go to its minimum value. All right. And I'm happy with this configuration with my built-in I/O to my I/O base. All right. Now I've got a couple of digital I/O modules. Now generally there's almost nothing you have to configure with digital I/O unless, and I'll double click here, unless you want to go with negative logic inputs, because the default input filtering and not holding any outputs to last state is generally what we want. But if we do want to change to negative logic inputs, we would have to change that here. I'm not going to do that on either this module or the next one. Okay, so there's nothing really I need to change from the defaults here. On my ADU100, I'll go ahead and set that up for thermocouple. Let's say J-type thermocouple on all 4 channels. All right, and I'll leave it at the default of degrees Celsius. Okay, now my update method, I want to update faster than every half second. Let's say I'm going to do it it's temperature, so it's probably not updating all that fast in real world. So I'm going to say 100 milliseconds. If I had some faster type processes going on here, I might set this to 25 milliseconds or something. But this is the frequency at which this module is going to be distributing new, or broadcasting, if you will, new readings for these 4 channels. All right, and then again, we have our ability to use filtering, and I'll set it to a value of 3, again, to achieve some additional stability at the cost of a little bit of update rate. Okay, so there we go. That configuration, to my liking at least, is done. All right, so the next thing I'm going to do is I'm going to download this configuration to my OCS. All right. It's going to warn me that be careful, because I'm using Ethernet to communicate to the module, to the OCS. Be careful that you don't accidentally overwrite your IP address to the wrong value and lose communications halfway through, but that's not a problem in my case. All right, let's switch back to our overhead view now, or back to our benchtop view, and see what's happening. Well, look at that. We have all solids happening on our I/O base, so that looks like to be up and running. Now let's jump to the system menu on our OCS and see if we see anything for the OCS-I/O populated there. This is a shortcut I've created to get me to the I/O configuration screen. And if I hit enter one more time, it will take me to the OCS-I/O screen. And sure enough, look at that. It found the base. If I hit enter again, it will show me the populated modules along with the UUID that is sitting right there for the base that was populated. Okay, terrific. So that's all working. All right, so that is the really straightforward approach for configuring a single rack of OCS-I/O. Okay, for my next demonstration, I'm going to show you how you can swap out a CNX base without opening Cscape. So we're going to swap something out in the field, and we don't want to have to open up Cscape and drag our laptop out to the floor. I mean, if this is an OEM machine, we want to just be able to swap out our component and move on our merry way. Okay, so let's take a look at this. So what I'm going to do now is I'm going to go ahead and power the system down. All right, and I'm going to pull out my, I'm going to pop the power connector from the existing base. All right, disconnect the communication cables, save that terminating resistor, and then I'm going to remove the existing base, assuming there's something wrong with that one. Okay. And next thing I'm going to do is I'm going to add in a new base. So this is my new replacement that I got from the factory. All right. So I'll reconnect my OCS cable and my terminating resistor. I'll reconnect my power cable to the new base. And let's go ahead and power up and see what happens. Okay. So we are in the process of booting up from an OCS and OCS-I/O perspective. Okay, we've got flashing lights. Obviously, we're not booted yet. And now we're booted. The OCS is booted, and we still have flashing lights on the OCS-IO. Now let's give it a few seconds and see if this automatically recovers and just takes off or not. Look at that. Okay, so it took a few extra seconds to work everything out, but it was able to automatically find that new base, determine that everything was normal except there was a new base connected, swap out the UUID and its memory table of the OCS, and we're back up and running again. Okay, so that's all there is to swapping out a CNX base without having to open Cscape or do anything else. Okay, for the next demonstration, we're going to configure 2 OCS-IO bases automatically from Cscape. And we're going to start with both bases effectively physically installed and powered up, but only the first base is connected. So I've got the cable to the OCS and the terminating resistor on the first base. The second base is not connected to the C-scan network. Okay, and you'll see why I did that here in a minute. All right, let's head to Cscape, go back to the IO configuration, to the CAN tab, add OCS-IO tab, CNX 116, and auto-populate all. Okay? It's asking me if I want to auto-populate and that it will overwrite any previous populations. It finds that first base because that's the only one connected. I say yes. It's going to say auto-populate complete. Okay, so that's good. All right, so it found the first one and assigned it as ID number 1. So the reason I did that is because I want this base here to be number 1. All right, that's what I've decided. So that's why I only connected the first base to the network. Okay, now we're ready to physically connect the second base. So I'll move my terminating resistor and then connect the cable that connects the 2 bases to each other. This is now the new end of the network. Now I'm going to go back to Cscape, and I'm going to hit Add Base. And again, I'm adding an OCS-IO CNX base. And again, I'm going to hit the Auto Populate All button. Okay? All right, it's going out there and finding this new base, which it's calling number 2. It's auto-populating it. Now, it's telling me, okay, these are the 2 that I've found, and these are the only 2 I have, obviously. I say okay, and now it's got both of the bases. Base 1 and base 2 are the default names, and I can go in and double-click and configure all the details for each of these 2 bases, just like I did for a single base. Okay, in this demonstration, we're going to take a look at what happens if we need to swap out a base in a multi-base system. Okay, so we've got a multi-base system already set up here. It's already up and going. We can take a look at the OCS-IO configuration. We can see we have 2 bases. We've got base 1 that has a UUID that starts with 001A. We've got a base 2 that starts with UUID 2A. All right, and we're going to swap one of these out. All right. Okay, so let's assume this one, for whatever reason, we need to swap it out. So let's go ahead and I'm going to power down. I don't think you'd necessarily have to, but I'm going to power down. Pull the plugs here. Actually, I don't need to pull this one since there's nothing connected to it. We'll disconnect the network. And then let's pop this module here. And we're going to put the new one in. Okay, so this is a different one. All right, I'll connect the network. I'll connect the power connector. Okay, and of course everything's powered down now. So, all right. Now I'm going to power up again. And we'll see what happens. If you remember when we had a single base, everything just kind of, after a few extra seconds of boot up time, everything came up and booted when we had to swap out the CNX unit in the main base. Okay, so first rack working fine, fully up and running. Second rack still sitting there flashing. So let's see, let's give it a few more seconds and see if it automatically starts working or not. Okay, so let's say that it's not going to recover automatically. So let's see what we can do to get the system back up and running without getting Cscape opened, which is obviously what we don't want to do in this scenario. Okay, so I'm going to go to the system menu. Got my handy dandy shortcut here. Go to OCS-IO configuration. Go to rack 2 because that's the one that's faulted and the one I want to replace. Hit enter. Okay, now I'm going to go down to UUID assign and hit enter twice. It says, hey, I found this available UUID that's new to me. All right, I say okay, or enter at least. All right, and okay, so it's enabled, it's assigned. We've got that new UUID going now, and sure enough, look right there, we are fully up and running. So again, this is another scenario where you can swap out a CNX base without having to get the software out to get things back up and running again. In this scenario, when you have multiple bases, you do have to use the system menu that's built into the OCS to get the new base assigned and get up and running. That's it for our topic for today. Let's wrap it up. OCS-IO configuration is a straightforward process. If Cscape is online with your OCS controller and the OCS-IO, then the IO base can be auto-populated in Cscape, which can save you a little bit of time. If ever in the future you need to replace a base for any reason or an IO module in the field for any reason, both of those tasks can be done without any Cscape intervention whatsoever, even on a multiple base system. Okay, let's take a look at what's coming up through the rest of February. Next week, we're going to be covering thermistors for the very first time. Yes, we've covered thermocouples, we've covered RTDs. Those are different types of temperature sensors. We've never covered thermistors before, so we'll be covering those next week. And then the last couple of topics in February should be fun. We've got a cooperative live stream with another company, Stalin. They've got a very cool solar shield product that any of you that are using OCS in an outdoor application should really take a look at. The sun can definitely have an impact on your control system if you're not careful. One of the options you have to minimize the impact the sun can have on your application is the Stalin Solar Shield. So we're going to show that to you on February 21st. And then to wrap up the month, we have a requested topic by a customer. They wanted to know if I've got multiple OCSs in kind of a warm backup type situation, how can I share remote I/O or expansion I/O with two OCSs, again, in a warm backup situation. So I'm going to review that with you for the last Tuesday in February. All right, don't forget we're here every Tuesday at 2 o'clock with a brand new video, either fully live or streamed to you live with someone standing by to answer your questions. And if you're watching this on replay, no matter what the video is, don't hesitate to give us your comments and your questions in the comment section, and we'll get those answered just as soon as we can. All right, we're celebrating 10 years at the Horner Lighting Group, so don't forget to check out those Horner Lighting videos. You'll find some really great products, whether you're talking about general lighting in an industrial setting, whether you're talking about some high-tech inspection lights, maybe for paint systems or something that's got a lot of finish requirements. Whatever your requirements are for lighting, check out the Horner Lighting videos on our YouTube channel. Now, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.